You will need to be able to determine if the conformation of your chiral centers. In order to do this, first you must identify a chiral center. This carbon is chiral. Now we need to go ahead and determine whether it is R or S conformation. To determine R or S conformation, you will have to rank the atoms attached to this chiral carbon. The way you do that is you will have to rank them based off of their size or molecular weight. The larger molecular weight the atom is, the higher the ranking it will get. You will rank from 1 to 4, 1 being the highest rank and 4 being the lowest rank. Let's redraw this molecule and begin the ranking. We know that this carbon has a hydrogen in the back position or in the the dashed attachment. So now we can go ahead and begin to rank this molecule. Bromine is the largest of the 4 attachments, and so it will get the 1 ranking. Hydrogen is the smallest molecular weight on the periodic table, so when you see it, most likely it's getting the 4 ranking, which is the least or the smallest size. Next, we will look at the other 2 attachments. We have a carbon and a carbon. And since they're both equal, we're going to have to find a way to distinguish between them. To do this, you have to look at the other attachments that are attached to those carbons. This carbon right here has 1, 2, 3 hydrogens attached. And so I call this an H ranking. This carbon has 1, 2 hydrogens attached, and another carbon attached to it. So this gets a CH ranking. Because this carbon has a carbon attached to it, it gets the higher ranking when looking at or distinguishing between these 2 carbons. So this carbon is 2 and this carbon is 3. Let's draw it again with the rankings so it looks a little cleaner. Bromine's 1, hydrogen's 4, this is 2, and this is 3. Now that you have done the ranking of the carbons, or the chiral carbon, you want to go ahead and ignore or put the position 4 in the back position. And so the hydrogen is already in the back position, and it is position 4, so we can go ahead and ignore it. And so I'm going to erase it. And now we have the 1, 2, 3 rankings. And what I'm going to do is draw a circle starting at 1 and ending at 3. And I'm going to determine whether it's moving in a clockwise or counterclockwise pattern. This is a clockwise pattern. And clockwise means that this conformation is R. Let's try a different molecule. This molecule has 1 chiral center. Its chiral center is located here. It has 4 different attachments. We need to rank these 4 different attachments. We know that there is a hydrogen not drawn here, and it would be in the wedge position. Hydrogen's probably going to automatically get ranked as 4, like I said before, and so we're going to stick with that. Then we're going to look at the other positions. This is carbon, carbon, and carbon. We'll rank them just like we did before based off of the type of attachments that are attached to these carbons. This one is 3 hydrogens, so it's a HHH. The one on top is 2 hydrogens and 1 carbon, so we have a CHH attachment. And the one on the bottom, this one actually has 2 attachments to carbon. If you notice, it's part of a double bond, and you have to count the double bond twice because it's 2 bonds. So we're going to say it has carbon, carbon, and then 1 hydrogen. Now that we have done this, we can go ahead and figure out which carbon will get the higher ranking. This carbon on the bottom that has 2 attachments to carbon gets the ranking of 1. The carbon on top that has 1 attachment to carbon gets the ranking of 2. And then the carbon with the 3 hydrogens attached to it is 3. We can redraw this so it's cleaner with just the rankings. There's a hydrogen. So this is 4, that's 3, this is 2, and that's 1. Now we have to make sure that the 4 position is in the back, and in this case it is not. So we're going to have to do something to put it into the back position. In order to do this, I'm going to draw a skeletal structure of just the bonds without the atoms attached in the same exact pattern they are drawn above. I just took a snapshot of this area. I did not put in any atoms. Now I'm going to put the rankings in. 1, 2, 4, and 3. And now we are going to move the 4 into the back position, which is going to require us to switch positions with the 3. So I'm going to draw one more time that skeletal structure. That skeletal structure does not change in shape or pattern. The 4 goes on the dashed line, the 3 goes on the wedge. So we switched those two. But if you switch one part of the molecule, you also have to switch the other part. And so you're going to see the 2 and the 1 positions also switch. So the 2 gets placed on the bottom, and the 1 gets placed on that top right. Now that we have the 4th position in the back, I am able to erase it so that I could ignore it while I am drawing my circle to determine confirmation. We will start at 1, go to 2, and to 3. This is a clockwise pattern, and just like before, clockwise equals R. Let's try one more so we can see what the counterclockwise looks like. This one looks similar to the one on top, except I switched the bromine out for chlorine, and I put it on a dash instead of a wedge. We know that this position, or this carbon, is chiral. We also know that it has a hydrogen coming in the front or the wedge position. Hydrogen, like I said, will get ranked 4. Chlorine is the largest of the atoms attached to that carbon, so it gets 1. And then one more time we have carbon and carbon, and we've seen before this type of ranking. This is an HHH carbon, and this is a CHH carbon. The CHH carbon outranks the HHH carbon, and so this carbon is 2, and then that makes this carbon 3. One more time, the hydrogen is not in the back position, so I'm going to have to draw that skeletal structure again, not drawing in any of the atoms, just the skeletal bonds. And I'm going to put in the rankings: 1, 4, 2, and 3. Okay, and so I need to switch the 4 and the 1 so that the 4 gets placed onto the back or the dashed position. So I'll draw it one more time again, putting the 4 on the dash and the 1 on the wedge. But that also means I need to switch the other two positions, and the 2 gets placed on the left and the 3 gets placed on the right. Now that I have done this correctly and the hydrogen or the 4th position is on the dash line, I can erase it and ignore it. Now I will do my circle starting at 1, going to 2, 3, and this is a counterclockwise movement, which means this is S confirmation. You have now seen how to identify chiral centers and how to determine their confirmation being R or S. Hopefully this helps you through your week, and I wish you all the best in the material this week.